So good day everyone. Now I'm going to pick a kind of signal or uh yeah, a kind of signal from continuous time and discrete time signal to explain. So we were given a task to code and plot different signals. We have here unit ramp function, and we also have rectangular pulse function, triangular pulse function, sinusoidal signal, and lastly we have exponential signal. So now I'm going to discuss the exponential signal. So exponential signal, as you from its, what do you call that, name, from the name exponential, so it depends on the exponent of the equation given or the function given. So now I will going to discuss my example. Example number 1, the function of I is equals to 2 exponent negative 0.1 t times sine pi times t. So here, this is the time variable. So this at the center will determine the smoothness of my wave, and from 0 to 8. So here, create the exponential signal. So this is the exponential signal. I just defined, or I just described what it says here. So I put it there. 2 times exponential 0 negative 0.1 times t times sine pi times t. So I plotted it. This code t, this is the t, the time variable, then the exponential signal, then I also declare its line width of 2. So its labels, x label t, for y label the function, and the title, of course the title. So now, so this wave is a sinusoidal signal modulated by an exponential decay. So sinusoidal. Though it is an exponential decay, but its wave is like a sinusoidal signal. So the exponential negative 0.1 t, this one, it defines whether the wave will be increasing or decreasing. So as t increases, the exponential term decreases because it is negative. So if your exponent is negative, your wave will be decreasing. But if your exponent is positive, your wave will be increasing, causing, so this equation causes the amplitude of the signal to decrease over time. So the term sine pi times r represents a sinusoidal wave with a frequency of pi. Pi is half the period of the standard of sine wave. So this part of the equation introduces the oscillations. So what is oscillations? This is the oscillations, the waves, every wave that they created, like that, the period. This causes the signal to vary in amplitude periodically. The entire signal is scaled by the constant factor 2. this one, the constant factor 2, which determines the initial amplitude of the signal. So the initial amplitude of the signal is 2. This 2. The amplitude, it's this part of the wave is the peak amplitude. This is the first or the initial amplitude of the signal. So that's it for the first example. As for the second example, we have g the function of t, 2 times exponential negative 0.4 t cosine 4 times pi times t plus 1.5 exponential negative 0.2 times t. So this is the time variable. Then the function I just described what it is written here. So the plot, the time variable, the function, the line width, and the width, and its labels. And here, the same with the first example, this exponential, this describes or defines how your wave is going to be, like will it decrease or will it increase. So since we have a negative here, so basically your wave will be decreasing. And the term here, cosine 4 times pi times t, represents a cosine wave with a frequency of 4 times pi, 4 pi. So the same with the first example, this introduces the oscillation. The amplitude of the cosine wave is further scaled by the constant factor of 2. So what is the difference between this cosine modulation and this sinusoidal modulation? So as you can observe, in sinusoidal modulation, it starts with a 0 phase shift. As for the cosine, it starts with a 90 degrees phase shift. Phase shift. It starts with a 90 degrees phase shift. So it starts with the middle of the peak amplitude in the center. So to wrap it all up, the function, this one, gt, both of the function starts with initial amplitude, undergoes exponential decay. So the exponential decay, this one, the exponential, and modulated by this sinusoidal modulation or the cosine wave. So the exponential decay, these negatives here, causes the modulation to decrease. So that's all for the exponential signal. Thank you.